Welcome in our today's mathematics lesson, of which we are still going on with the equations, that is equation 2, and today I want us to look at equations with fractions. When we talk about equations with fractions, previously we've seen what we call algebraic fractions. So when you talk about equations with fractions, we are trying to look at those algebraic equations which are equated. Because when you say equation, it simply means that we have one side of the left-hand side, we have an expression, and on the right-hand side, we also have it equated to a certain value or a certain expression. That's why we call it an equation. So equations with fractions will mean we have got fractions with numerals, but they are equated to the others. So you should be able to recall when you talk about a fraction like this is an algebraic fraction. But how do we make it an equation? If I can equate this to a number like maybe 4, then this one is an equation with fractions. But now, I want us to recall what do we understand when we write a fraction like x over 3. X over 3 is the same as x divided by 3. So if that is the case, if this is the case, then it means that when you have a number like this and it is equated elsewhere and you want to solve it, then it will mean that we do the following. Looking at this, we have x over 3 is equals to 10. Here, we are interested in finding the value of x. And in our previous lesson, we say when we find the value of x, it means we are solving the equation. So we are to solve the equation here. For this particular case, it means that x over 3 is the same as x divided by 3. Therefore, if we want to remain with x or so resolve for x, then we shall multiply here by 3 and multiply on the right hand side by 3 so that this one becomes x. On the left hand side, we shall have x is equals to 10 times 3, which is 30. And this is where our solution is. So we need to know that every time we are having such a case, that is x or a fractional part, then if the denominator is there and is a numeral, then to remove it, we need to multiply, because dividing a number is the same as multiplying the numbers. So we need to consider the following when we are looking at equations with fractions. We should understand that a over b simply means a divided by b. It means a divided by b. And if we are to solve an equation, then it is necessary that when we have a fraction on one side, like we have q over 4 is equals to 12, when we have such case, then it simply means to solve this, we shall multiply here by 4 and multiply this one by 4 so that we remain with q and is equals to 12 times 4. And when you work out that, you'll find that q is equals to 48. Q is 48. So we should observe these rules as we go through equations with fractions. Let us look at examples and see how we should be able. Let us look at examples and see how we should be able to solve equations with fractions. Solve the following equations systematically. A, we have 4x over 3 is equals to 8. B, we have 4y plus 15 over 9 is equals to 3. Starting with this first one, we have 4x over 3, and we have it equated to 8. So from this, what we've learned, we shall have to multiply here by 3 because the denominator is 3. So we are removing the denominator and multiply this side also by 3, so that we shall remain with 4x is equals to 8 times 3. So 4x is equals to 24. Then we divide by 4 and divide by 4 the other side. Then we shall remain with x is equals to 24 divided by 4, which is 6. Taking you back here, the purpose why we remain with 4 here, just to illustrate, is simply here when you take 4x and then you choose 4x over 3, and then you multiply by 3, by 3 is 1, by 3 is 1. That is how we are remaining with 4x here. So we should be able to reduce this to that. You can always check your answer and confirm that you have the correct answer. So this x equals to 6 is the solution for our question. Let us see if we have the right answer or not by substituting on the left-hand side. If we are to substitute 4x and x is 6 over 3, then is equals to 8. Then this one will mean that 4 times 6 is 24. 24 divided by 3 is 8. So it becomes 8 is equals to 8. So it is very true that from this equation, the value of x is equals to 6. As we advance further, let us look at the second part. And the second part, the question now is a bit different. On the left side, we have algebraic fraction, and it is equated to 3. So when we have y plus 15 over 9 is equals to 3. The very first thing to be dealt with is the denominator. And when we have the denominator, we say to remove the denominator, we shall be required to multiply by the value of the denominator, which is multiplying by 9. So when you multiply the whole of this by 9, what remains is 4y plus 15. That is what remains because 9 and 9 will cancel. And the other side, 27, because 3 times 9 is 27. Then from here, we want to remain with the unknown, that is 4y. So we shall subtract 15 from both sides. When you subtract 15 from both sides, you remain here with 4y is equals to 27 minus 15, this one will give us 12. So from here, we shall be required to divide by 4 and divide by 4 the other side. If 4y divided by 4, you get its y is equals to 12 divided by 4, you find it is 3. So this procedure is called solving an equation. Y is equals to 3 is called the solution of the equation. So the method here we have solved using in a systematic manner. So that is the value of y, which can be substituted And every time you substitute it, you'll find that it is going to do what? It's going to agree that is the left-hand side and the right-hand side. Just to work out mentally, it is 4 times y, y is 3, that gives us 12. 12 plus 15 is 27. 27 divided by 9 is 3. So this 3 is equals to 3 on the other side. We have the following questions. 4 plus 5x over 2 is equals to 29, and we have 7 minus 2x over 3 is equals to 5. Now, take note here that what we have here this time is slightly different. We have been handling fractions and we were eliminating the denominators first, but if it is written in this particular manner, we shall not rush to start eliminating the denominator because 4 is a whole number and it's on its own. So we simply start by actually working out the constant 4. And how to remove the constant 4? We shall take the left-hand side and subtract 4, go to the right-hand side and subtract 4. When you subtract 4 from both sides, what remains here? This 4 minus 4 is 0, so we shall remain with 5x over 2, and 5x over 2 is equals to what? To 29 minus 4, which is 25. 29 minus 4, which is 25. Now we have an algebraic fraction on the left-hand side, which you realize that now this one can be actually solved in systematically still, and here we shall take this side and multiply by the denominator, which is 2, and multiply the other side again by the denominator, which is 2. 5x over 2 times 2 will give us 5x is equals to 25 times 2, which will give us 50. We have 5x is equals to 50, then we shall divide here by 5, so that 5x divided by 5 is x is equals to 50. We take it, we divide by 5. 50 divided by 5 will give us 10. So we can simply say that the solution to this equation is x is equals to 10. We have been able to solve the equation by finding the value of x as 10. For the last one, which again will employ a different approach, this question is almost similar with the other one that we've covered, but you'll notice that the coefficient of x is minus, it's a negative. The coefficient of x here is negative 2 over 3, and that is where the interest is as we do the solving, or we go about solving this particular equation. So as I said earlier, we have a whole number and then we have a fractional part. We first deal with the first part, so we shall take this by simply taking the left-hand side and subtracting 7. So when you subtract 7 from both sides, you remain with minus 2x over 3 is equals to 5 minus 7. In our integers, when we are dealing with both positive and negative numbers, we saw that when you subtract a larger number, then the result is negative. So 5 minus 7 will give us minus 2. Now, having reached here, we need to eliminate the denominator. We need to remove the denominator, and the denominator that we have is 3, so we shall multiply both sides by 3. If you do that, minus 2x over 3 times 3 will remain with minus 2x is equals to minus 2 times 3, which gives us minus 6. At this point now, our interest is to remain with x, So we take this side, we divide by what? By minus 2. The other side we also divide by minus 2. A negative and a negative always gives us a positive. So minus 2x divided by minus 2 is positive x, is equals to minus 6 divided by minus 2 will give us a positive 3. So this one is telling us that the solution of this equation after solving is x is equals to what? X is equals to 3. X is equals to 3. So if you are very keen here, you must have realized that the approach we are giving in these equations with fractions is just similar to what we've been doing previously on integers, on numbers, on algebra, and so on. But the major interest is to observe the method as you approach the question and also solve it systematically using the correct method. I want us to look at the fractional solutions. That is further questions touching on the equations with fractions. So now I want us to consider this because it's part of the questions we normally come across, and sometimes when you work out you'll find that you are even getting your answer in form of a fraction, but before that, we can have a group of fractions which can be reduced into one equivalent fraction. So, for example, if you have if you look at these fractions, we have what we call algebraic fractions, and the two of them can be combined to form one equivalent fractions. So if we can form one equivalent fraction of the two, we cannot get that one equivalent fraction because the denominators are not the same. So when we talk about fractional solution, we want to look at groups of fractions which is going to give us either to be equated to a number, and then we solve. But before we do that, let us remind ourselves, how do we get an equivalent fraction given a group of fractions like this? So we need first to get what we call the lowest common denominator of 3 and 4 for this case, which is what? 12. 12 divided by 3 is 4. 4 times 2 gives us 8x. Then 12 divided by 4 is 3. 3 times 5x gives us 15x. Because 8x and 15x are like terms, you can bring them together so that you have a total of 23x over 12. Now, this 23x over 12 is an equivalent fraction, algebraic fraction of these two. Now, in solving or applying fractional solutions, we shall look at such case where we are equating a group of fractions to a number and solving it. So we should be able to first make the side to have equivalent fraction, and then we solve it. Solve the following. 2x over 3 plus 5x over 4 is equal to 46. Now, if you look at this, we have a group of fractions, and we need to come up with equivalent algebraic fraction for these two so that we are now able to start solving. We cannot just start working out and solving directly until we have equivalent fraction of this group here. And for us to get the equivalent fraction of this group here, first, we shall treat the left-hand side until we get an equivalent algebraic fraction. So taking this, The lowest common multiple of the denominators 3 and 4 is 12. 12 divided by 3 is 4. 4 times 2x is 8x. Then plus 12 divided by 4 is 3. 3 times 5x gives us 15x. This one is equals to 46. If you combine this, you get it is 23. X over 12 is equals to 46. So at this point now, we are able now to work out what we require. And this one here, we shall divide by 12 and divide by 12 this other side. So when you do that, you find that 23 over 12 to divide, shall not divide is a denominator. Let us take note of that. This is a denominator. When we have it as a denominator, we multiply, not divide. So we shall multiply by 12 both sides. So if you happen to multiply by 12, then we shall remain 23 over 12, 23x over 12 times 12, you get 23x. On the other side, we have 46 multiplied by 12. So the moment you reach there, then we are remaining with only what? We are only remaining with 23x is equals to 46 times 12. On this other side, what you need to do to remain with x here, we shall divide by 23 and divide by 23. If you do that, you find that x is equals to 46 times 12 divided by 23. By 23 here is 1, by 23 here is 2. 2 times 12 is 24. So x is equals to 24. So we have a solution for this algebraic group of algebraic fraction which was equated to 46. And here, for us to work out this, we had to look for one equivalent algebraic fraction and form an equation from there. And that's how we arrive at this answer of x is equal to 24. Let us look at another one again, which still has a group of algebraic fractions, and see how we can form a single equivalent algebraic fraction and equate it as we solve. We are to solve 4 is equals to x over 2 minus x over 3. X over 2 minus x over 3. Now you realize that this time now we have on the left-hand side what we have equated to, and on the right-hand side is where we have a group of algebraic fractions which we need to solve for the unknown. So there is nothing wrong, as I told you earlier on, that we are allowed sometimes to interchange so that what we are solving comes on the left-hand side for easier working. But there's nothing wrong if we can also still handle it the way it is. Basically, we shall concentrate on the right-hand side until we get an equivalent fraction of these two, and then we equate it to 4. So for this case, we have the denominators 2 and 3, which implies that we cannot add the numerators because the denominators are different. That calls for us to look for what we call the least or the lowest common denominator. And the lowest common denominator for 3 and 2, you'll find that it is 6. So let us have 6 as our lowest common denominator. 6 divided by 2 is 3. 3 times x is 3x minus, we maintain a sign, 6 divided by 3 is 2, and 2 times x is 2x. Remember, this side we have a 4. If you choose to interchange, it's allowed, but let us get the equivalent fraction first, and then we can interchange. So this is the same as 4 is equals to 3x minus 2x. 3x minus 2x, we shall remain with x over 6. That is what we have as our equivalent fraction of these two. So to solve this now, we are at x over 6. I'm interchanging the right-hand side and the left-hand side is equals to 4. So this, we shall multiply here by 6 and multiply that side again by 6. When you multiply x over 6 by 6, you will remain with x is equals to, and then you take 4 multiplied by 6, you get what? You get 24. So we already have the value of x, and if we can check to confirm, we can bring x here and see whether we shall get what we want. We want to check our answer by substituting in the original equation. Let us check that and see. We have x equals to 24. Is it true that 4 is equals to x over 2 and x is 24? So 24 over 2 minus 24 over 3. 24 over 2 is 12. 24 over 3 is 8. Is it true that 4 is equals to 12 minus 8? Yes, it is true. So our solution for this equation is x is equal to 24. That is it about fractions. We have been looking at equations with pronumerals on one side. Now, I want us to look at equations with pronumerals on both sides. That is on the left-hand side and on the right-hand side. As we saw earlier that when we are talking about equivalent equations, we are simply saying you maintain the principle. If you subtract left-hand side, you subtract right-hand side. If you interchange, you do the same. If you multiply, you do the same on both sides. Now, but this case now, we find that we have got the pronumeral or the unknown on both sides. So the issue here is how do we solve such questions given that we have got pronumerals on the left-hand side, we have got also a pronumeral on the right-hand side. It is necessary that we learn how to bring them together, collect like terms, and start solving them at a time. For example, when you say there is pronumeral on both sides, look at this. Now, this is the situation we are talking about. We have x as a pronumeral on the left-hand side. We have x as a pronumeral on the right-hand side. Now, for such case, it is necessary that you rearrange until you have all the pronumerals on one side. Because we are equating, let us use the procedure of equivalence to work out this. So, for this case, if we want to work out such that maybe we have the x on this side, then we shall be required to subtract 3x this side and subtract 3x this side. So that one will mean here that this is 11 plus 5x minus 3x is equals to 7 plus 3x minus 3x. So you realize that 3x minus 3x is a 0, so we are remaining with 7 on this side. Then 5x minus 3x gives us 2x. So this is 11 minus 2x is equals to 7. So this one here is simply 11 minus 2x is equals to 7. If this is what we have now reduced it into our linear equation, as we always know, where we have a pronumeral on one side and it can be solved systematically until you arrive at a question where, at the point where the value of x is known. So the main thing is how to bring the pronumeral on the same side. So what are we supposed to know about this? Now, it is very, very important here. It is very important here to know that if we have pronumerals on both sides, then we shall have to observe the rules of equivalence as we go about bringing the unknown or pronumeral on side. So, at any given time, when you have equations with pronumerals on both sides, we shall make sure that the new equation that is formed is equivalent to the original equation, and that is done by subtracting from both sides, or adding from both sides, or dividing both sides, and so on. Now, what I'm trying to say here is this, that any equation you will form after this must remain an equivalent equation. For this case here, we have 2a the other side. On this other side again, we also have 5a on this side. So there is a necessity that we make sure that whatever we have remains equivalent. So we need to have the pronumeral on one side. So I've said we shall subtract 2a and subtract 2a. We've done it on both sides. If we do it on both sides, then it simply means what we have is simply equivalent. What we have is simply equivalent equation. So this one here will give us 13, and this one will give us 10 plus 3a. That is 5a minus 2a is 3a. So what we are saying, this one is still an equivalent equation. And we have been able to bring it together so that we are able to solve. Now, sometimes if you are not going to do it this way, sometimes you'll do it differently. You will swap. You will swap. And if you choose to swap the left-hand side and the right-hand side, then swap everything. There's nothing wrong if we swapped and had 13 plus 2a is equals to 10 plus 5a. This is still the same. We've not changed anything. And then it would be now here minus 5a and then minus 5a. What comes is 13 minus 2a minus 5 plus 2a minus 5a will be 13 minus 3a is equals to 10. This one again forms an equivalent equation. Having said that, let us now look at equations. Let us now look at questions and start solving them, given that we have pronumerals on either sides. Solve the following equations. A, we have 7t plus 4 is equals to 5t plus 10. And but B, we have 6x plus 4 is 6x plus 4 is equals to 22 minus 3x. Now, as you can see, we have t on the left-hand side. We also have t on the right-hand side. So here, we need to see where do we want our pronumeral to be. And in most cases, we prefer bringing the pronumeral on the left-hand side. So for this case, to solve, here, we shall subtract 5t here and subtract 5t here. So 7t minus 5t is 2t. Then plus 4 is equals to 5t minus 5t is 0, plus 10 is 10. So this forms an equivalent equation. It forms an equivalent equation to this. So we can move ahead and now solve by subtracting 4 here and subtracting 4 here, because this is a linear equation. As we have been doing it, we solve it systematically. This one will give us 2t is equals to 10 minus 4, which is 6. We divide by 2, divide by 2. We find that here we have t is equals to 6 over 2, which is what? which is 3. So we have been able to first bring the pronumeral on one side and solve the equation systematically until we have the value of t. For question 2 here, 6x plus 4 is equals to 22 minus 3x. We want to have the pronumeral on the left hand side, and then we have the constant on the right hand side, and then we resolve. So here, we need to actually bring the x on the other side. So we shall eliminate it from this. This is minus 3x. So to have it out, we shall do what? We shall add 3x on the right, add 3x on the left. So that we have minus 3x plus 3x is a 0. This side, 6x plus 3x will give us 9x. Then plus 4 is equals to 3 minus 3x plus 3x is a 0, then plus 22 is 22. Now we have a simple linear equation. We can now solve it, and we shall solve it by subtracting 4 here, subtracting 4 here. When you subtract 4 from both sides, you remain with 9x is equals to 22 minus 4, which is 18. You divide by 9, you divide by 9, you remain with x is equals to 18 divided by 9, which is 2. So the value of x at that point is 2. X is equals to 2. Last, we have 2u is equals to 7u minus 20. 2u is equals to 7u minus 20. We have u on the right-hand side, we have u on the left-hand side. Our approach is still the same. We decide we want to bring it on the left, fine. If we want to swap the two, we also, okay, let us try the situation here and see what we can do. Is it possible for us to swap? And if you don't want to swap, you can simply work the way it is. So I want us to start by swapping, so that we have 7u minus 20 is equals to 2u. There we are. Then now we want to have the pronumeral on one side. So we shall subtract 2u, subtract 2u here. Then we shall have 7u minus 2u is 5u is equals to, sorry, minus 20 is equals to 2u minus 2u is a 0. Then the next part is add 20, add 20. And this one will give us 5u minus 20 plus 20 is 5u is equals to 0 plus 20 is 20. Divide by 5, divide by 5, you get u is equals to 20 divided by 5, which is 4. 20 divided by 5, which is what? 4. That is what we have as a solution for this particular question. So when you look at this, you find that you should not be bothered at any given time. You should not be bothered at any given time, even if you find the pronumerals on either sides. Now, look at this question. Find the values of x and y in the following rectangle. A rectangle measures y plus 3, 3x plus 2, 3y minus 17, and 5x minus 10. Now, what do you understand about the properties of a rectangle? Just in groups of 2, discuss out and tell each other what do you know about the rectangle. And then from there, it is going to guide us and see how to approach this. Now, if you have done that, you must have really been told or realized that in a rectangle, 2 opposite sides are always equal. The length, the top and the bottom is equal, the left and the right is equal. In other words, here, it is true to say that y plus 3 is equals to 3y minus 17. So we can form one fractional equation, and then 3x, we can form one algebraic equation, and then 3x plus 2 is equals to 5x minus 10. Also, that is another equation. Let us start solving this. So let us equate this on that side. So it is true for this. This is the truth, that we have these sides equated to the other side. And now when you look at this, it is just the same what we've just seen through a few minutes ago, that we can be able to bring the pronumerals on one side. So let us start by working out. We can interchange it. I want to swap. So if we swap, we shall have 3y minus 17 is equals to y plus 3. So subtract y here, subtract y here. You will find that you have 3y minus y is 2y minus 17 is equals to 3. If you reach here now, we have 2y minus 17 is equals to 3. This side we add 17. This side we add 17. You'll find that you remain with 2y is equals to 3 plus 17, which is 20. And then divide by 2, divide by 2. You find that y is equals to 10. So you find that y is equals to 10. And if y is equals to 10, what are the dimensions of this side? Then you find that if you substitute y is 10, you find that this side measures 13 units. And this side is 10 times 3, which is 30. 30 minus 17, again you get it is 13. So you find that it's correct, 13 units on both sides. Let us look at the longest side and equate again 2. The equation will be 3x plus 2 is equals to 5x minus 10, which is the bottom here. We can simply start working by subtracting 5x and subtract 5x here. 3x minus 5x is negative 2x, then plus 2 is equals to negative 10. Then subtract 2, subtract 2. You'll find that what you get here is minus 2x plus 2 minus 2 is minus 2x is equals to minus 10 minus 2 is minus 12. So we now have minus 2x is equals to minus 12. Then we divide by minus 2. We divide by minus 2. Minus 2x divided by minus 2 is x. Minus 12 divided by minus 2 is 6. So you find that the value of x is 6 units. The value of x is 6 units. Can we take 6, substitute, and see if we shall get the two sides equal? 3x and x is 6, then plus 2. This is the same as 18 plus 2 is equals to 20. For this one, it is 5x and x is 6 minus 10. 6 times 5 is 30, 30 minus 10 is 20. So it's very correct that the value of x is 6. Now, find the area of the perimeter of this rectangle. Unlike the other one, we were only asked to find what? The values of x and y. This time now we need to find the area, we need to find the perimeter, and still we have been given no dimension but simply equations and pronumerals of their known letters. Or we have a rectangle measuring 2y minus 4 by 8x minus 21, y plus 8, and 4x plus 7. 4x plus 7. So from what we just saw earlier on, that a rectangle has two opposite sides equal, and therefore we are going to equate the sides and we solve for the pronumerals, and then we use the pronumerals, substitute to get the dimension of the rectangle, and we work out the solution. So starting from this, we find that we shall equate, let us start with the x. So 8x minus 21 is equals to this. So this should be equated to this one. And then from there, let us remove 4x. Let us remove 4x. We are subtracting. So 8x minus 4x is 4x, then minus 21 is equals to 7. Then plus 21, you find we remain here with 4x is equals to 7 plus 21, which is 28. And then we shall divide by 4. We divide by 4 here. When you do that, you'll find that x is equals to 28 divided by 4, which is 7. Let us move and solve for y. Here we shall equate again the 2, that is 2y minus 4 is equals to y plus 8. 2y minus 4 is equals to y plus 8. And then looking at this, we eliminate, we actually work on removing y here. So minus y, we shall remain 2y minus y is simply y, minus 4 is equals to 8. Then we shall add 4 here and add 4 here. We shall have y is equals to 8 plus 4, which is 12. So we have the value, the solution for x, and we also have the solution for y. But the main purpose here is to find the dimension of our rectangle. So let us get the dimension of the rectangle. To get the dimensions, we shall be required to substitute the values of our pronumerals so that we have the dimensions. So for the first part here, x, we have 8x minus 21, but x is 7, so we shall substitute where x is and put a 7. So this will be x into 7 minus 21. And if you work out that, you'll find that this is 56 minus 21, which will give us 35. It will give us 35. Can we confirm it mentally with this other side? 4 times 7 is 28. 28 plus 7 is 35. So it is true the length is 35. For the other side here, we have 2y minus 4. And y is what? 12. So 2 times 12, this is 2 times 12, is 2 times 12 minus 4. 2 times 12 is 24. 24 minus 4 is what? 20. And we can check out from this side, y is 12. 12 plus 8 gives us what? Gives us 20. So it is true that the dimension now is measuring 35 here, and this one is 20. So when you come back to the question now, having done that, The question is asking us to find the area and the perimeter. The area is length times breadth, which is simply 20 times 35. And then work out this one will give us 700 units, square units. And 700 square units. 700 square units. For the perimeter, we would have 20 plus 35 into bracket multiply by 2. 20 plus 35 is 55. 55 times 2 is what? 110 units. So the distance around the rectangle is 110. But the area is simply 700 square units. So that is how we work out the issue about equations with pronumerals on both sides. We should be able to handle other questions related to this. Now, in our next class, we shall be looking at the equations with brackets, but that is it for today. Thank you.